Welcome to Unit 5. Today we'll be looking at a more stronger exercise. Find the gradient function of the graph y equals to 2 over x. Find the gradient function of the graph y equals to 2 over x. Now, by now you know how to get coordinates of x and y, of p and q. So therefore, you have no issue now. So for p, which is usually the graph, the equation, the graph equation is simply what? X 2 over x. Now the coordinate for q will now be h and 2 all over x plus h. So if you have gotten this process, then you are on the course of trashing any differentiation that will come your way. So now we say gradient, you are no longer new to this word, gradient function. Following our exercise, you will now know that it's the difference in the y-axis all over the difference in the x-axis. So your q and p, this is the y2 and this is the y1. So what do? You just say 2 all over x plus h. If you like, put this one, say minus 2 all over x. Now, all over the difference in the x-axis is h. Now, this one is your gradient. This is now your gradient function. So what you do is to treat this equation or this fraction, which is the upper fraction, before you talk about the lower fraction, which is actually also called h over y. So let's deal with the upper one. Now we have 2 all over x plus h minus 2 all over 1 x. Sorry, this one is not, be careful please, is x plus h. Now we don't miss that. So it's also x plus h. Now don't cause any confusion there. So let me take it up. So what you have over x plus h minus 2 over x. Please, let us be consistent and be very careful. So now we want to treat this fraction. Your LCM for these denominators is simply x. Let's be consistent with our mode of writing x, please, so that by the time we are doing our subtraction and addition, we don't have two different sums. Let me be consistent with it. Our mode of writing x should be consistent since we have chosen this mode. Then therefore, we are saying x into what? X plus h. Fine enough. X plus h will cancel this. What you have there is x. So x times 2 is simply 2x. Put your minus sign. X into this will cancel this. You have this. So you have x plus h. Put your bracket. Times 2. So what we are going to do is to expand the top. So what you have will now be 2x. If you multiply this one, it becomes minus 2x. Because this is multiplying this. And when this also affects this, it becomes minus instead of plus. Because minus times plus will give you minus. So it will now become minus 2h. So it must be consistent. If you also expand this, it's going to give you x squared plus xh. Fine enough. If you have been able to get it, don't forget it's all over h over 1. So you discovered our gradient function is 2x minus 2x minus 2h all over x squared plus xh all over h over 1. We are making serious progress. So let's deal with the addition subtraction normally. 2x minus 2y. 2x minus 2x will cancel out. So what you have there is simply minus, please be careful, minus 2h all over what? X squared plus xh. Just invert our h over 1. So it becomes 1 all over 1 h. So just finish that. So we will now have minus 2h all over h, because this h is multiplying this, so it becomes h into x squared plus xh. Please be careful. This is not 1, 2, 3. So you are dealing with alphabets and you are not careful, you will just mess up. So what do you have? You now have expanded, first of all, so that it will be easier for you. Minus 2h all over x squared h, because h is multiplying x squared, plus sh squared. Please be careful. So, I have mentioned then that our gradient function is equal to, now, this is what we are dealing with, minus 2h all over x squared plus xh squared. X squared h plus sh squared. So we discovered that h is a common factor in this equation. So we can now say now that h into minus 2, we want to factorize h out so that h can cancel. We now have h into what? x squared plus xh, because h times x squared, h times xh will give you sh squared. So having done that, you discover that h will factor out. And what you actually have now is going to be minus 2 all over x squared plus xh. So having done that, when h tends to 0, xh is equals to 0. So therefore, our gradient function with this equation is simply what? Minus 2 all over x squared. So that is the end of this unit. We are going to be taking more serious equations, and please just follow up. You discover that it will be used to it. Thank you, as we meet in Unit 6.